So in this video, we are going to solve the question I have on the screen here. It says that a 5.0 volt stabilized power supply is required from a 12 volt DC input. The maximum power rating on the Zener diode is given to be 12 watts. Using the circuit below, calculate A, the maximum current flowing in the Zener diode, B, the value of the series resistor R, C, the load current IL if a load resistor of 1 kilo ohm is connected across the Zener diode, and then D, the total supply current IS. So those are what we've been asked to find. So the first one is the maximum current flowing through the Zener diode. So for us to be able to find the maximum current through the Zener diode, we are going to use the formula PZ mass. PZ mass equals IZ mass, which is the maximum current in the Zener diode, times VZ, which is the voltage in the Zener diode. This is the formula we're going to use. So now, with this formula, let's look at what you've been given. You've been given the maximum power in the Zener diode to be what? 2 watts. Okay, you've been given that one. So what else do we need? We need the voltage in the Zener diode. But in the question says what? A 5.0 stabilized power supply is required from what? A 12 volt DC. So that means that you need a voltage of what? 5.0 to the load. The load needs a voltage of what? 5.0 stabilized power supply. And the voltage in the load will be the same as the voltage in the Zener diode. So that's VL will be equal to VZ. Okay, the voltage in the load will be the same as the voltage in the Zener diode. So if the voltage in the load is 5.0, then the voltage in the Zener diode will also be what? 5.0. So that will be equal to 5.0 volts. Okay, so now you know the maximum power and then we know the voltage in the Zener diode, so we can therefore find our IZ mass. So IZ mass will then become PZ mass divided by what? VZ. So this is the formula we use. So now let's go ahead. So we know that PZ mass is 2. So that's 2 divided by VZ. That's the voltage in the Zener diode. Okay, which is given to be 5 volts. Okay, so this is what we have. So let's see what we get at the end. So that will be 2 divided by 5. So that gives me an answer of 0.4. Okay, now since our answer is very small, let's multiply by thousands. That our answer will be in milliampere. That be times 10 to the power 3. So let's see what we get. So that gave me 400 milliampere. So our answer will become 400 milliampere. So this will be the value of what? IZ mass. Okay, so now we've gotten the value of what? IZ mass. Let's go ahead and answer the second question. That's the B part. The B part says that we should find the value of the series resistor R. So I'm going to do that also. So when you look at this circuit here, you see that it is open at this side. Okay, which means that no current will flow through it. Okay, so what happens is that the current is coming from the source and it gets to this node. Since this side is open, it will not flow through it, so it will flow through the diode and then back into the circuit. Okay, so which means that the current in the diode will be the same as what the current in the resistor. So therefore we see that what IZ will be equal to what? IS. Okay, we see that what IZ will be equal to what? IS. Okay, so if that's the case, then this will be equal to 400 milliampere. Okay, because you know the current in the Zener diode is what? 400 milliampere. That's what we found. Okay, so we are going to use this same current for the source current. Okay, it's the same current that will be through this resistor here. Okay, so now you know that the voltage across the resistor, let's name this VR, will be equal to what? IS times what? R. So you want to find this R, so R will be equal to VR over what? IS. But we already know IS to be equal to what? 400 milliampere. So I'm going to find VR. Okay, so for us to be able to find VR, let's look at this circuit here. So just like this part of the circuit is not working since it is open. Okay, so we have the voltage input to be V in will be equal to VR plus VZ. Okay, so the voltage from the source will be equal to the voltage drop across this resistor and then across this Zener diode here. So if I want to make VR the subject, VR will be equal to what? V input minus what? Vz. So that will be the voltage in the resistor will be equal to the voltage from the source minus what? The voltage in the Zener diode. So the voltage from the source is given to be 12 volts. So that will be 12 volts minus the voltage in the Zener diode, which is what? Which is 5 volts. That will be 12 minus what? 5 over Is, which is given to be 400 milliamperes. So that will be 400 times 10 to the power what? Minus 3. So let's see the answer we get for this. So that will be 12 minus 5. So that will be 7 divided by 400 times 10 to the power minus 3. So that gave me a resistor value of what? 7.5. That gave me a resistance value of what? 7.5 ohms. So that's the value of the series resistor R here. Okay. So B, we got R to be equal to 17.5 ohms. Okay. So let's look at the third part of the question. It says that what the load current IL if a load resistor of what 1 kilo ohm is connected across the Zener diode. So you should find the load current IL if a load resistor of what 1 kilo ohm is connected across the Zener diode. So in this case, the load resistor is connected here. So let's find the load current that will be in it. Okay, so you know that voltage equals what? Current times resistance here. So current will be equal to voltage over what? Resistance. Okay, so in this case that will be VL over what? RL. So we know RL to be given, RL has been given to us to be 1 kilo ohm here. So that will be VL divided by 1 times 10 to the power what? 1 times 10 to the power 3. That's kilo. Okay, so now we need VL. Okay, so we need VL. So we're going to find VL. We know that VL is the voltage across the load and the same as the voltage across the Zener diode. And then in this case, we've been given the voltage across the load to be what? 5.0 volts. So that will be equal to 5 over 1 times 10 to the power 3. So let's see what we get for that. That will be 5 over 1000. Okay, so that gave me an answer of 0.005 ampere, but it's too small, so let's multiply by 1000. Okay, so that we will change it into milliampere. So this will give me 5 milliampere. So that will be the load current when the load resistance is what? 1 kilo ohm. So the C part, IL will be equal to 5 milliampere. Okay, so now let's continue and then solve for the last part. Okay, so the question now says that what? Now you should find for the total supply current IS. So now you are going to find for the total supply current IS. Okay, so from here, when we look at this, you know that what the current moving towards the node because the current moving away from the node. Okay, so IS will be equal to IZ plus IL. Okay, so in this case, a load is connected here, so current will flow through this direction, and then current will also flow through this direction since there is a load connected. Okay, so if that's the case, then what will be the total current here from the source? Okay, so if that's the case, then what will be the total current from the source? So the total current from the source will now become IZ mass plus IL. So that will be the current in the Zener diode plus or the current in the load. So that will be 400 milliampere plus IL, which is what? 5 milliampere. So let's see what this will give us. So this will give us 405 milliampere. So that will be the value of the total current supply here when a resistor of what? 1 kilo ohm is connected to the load. Okay, so that's all for the question.